A very good morning to all. Myself, Ani Sultana, working as assistant professor, belongs to Department of Management Studies, SNS College of Technology. So today's discussion is with regard to the subject, that is fundamentals of data analysis. So this is the practical subject, and today we are going to learn the topic, that is finding the equation of a line. So this is the exercise we are going to practice using the MS Excel software. But before that, we have to understand how what is the manual, how we manually calculate the regression, and what is the uses of regression with the relevant examples, and how that this we are going to apply in the Excel software. Is to begin with, why we should understand what is the necessary to learn the equation of a line. So we have three aspects. First one, it is model relationships. Second one, to enable the predictors. And third, it is the statistical foundation. So model relationship means, suppose we assume we have two variables, that is x and y. Say for example, variable 1 is x, variable 2 is y. So here y is the dependent variable and x is the independent variable. We assume as it is. So x means which is independent and y it is dependent on x. Suppose if you take the examples of advertisement and sales, so we have to define which is the independent and which is the dependent. So we explain the model relationship to test the predictions. Suppose say for example, if x is increasing, what is the impact of x on y? That is, if we assume the independent variable x as advertisement, suppose if we increase the cost of spend towards the advertisement, what is the effect of sales with respect to advertisement? Let us see this example in the further presentation slides, and also it plays evidence as a statistical foundation. So we have the formula to calculate regression. To calculate regression, we need to know the slope and intercept. So this is the equation. We know that y is equal to mx plus b is the regression equation. Normally here in this, it is represented that is a intercept slope as m and b as intercept. So here y it is the dependent variable, x it is the independent variable, m it is the slope of the equation, and b it is the intercept on y. Okay, so to calculate the slope, we know the formula y1 minus y minus y1 into is equal to m into x minus x1. That is, y minus y1 is equal to slope into x1 minus x1. So this is the standard equation form of ax plus by plus c. So if we calculate manually, we have to follow all these procedures. But with the help of the Excel, when we apply, it is just a very simple formula to understand, to do this analysis. Okay, to start with, first we need to understand the slope m. So slope represents the rise over run, the change in y divided by the change in x. That is the changes in y divided by changes in x. So we have already shared the formula, that is m is equal to y2 minus y1 divided by x2 minus x1. Next, this is the practical example of how the slope is been calculated. Suppose we imagine the y2 is 11 and y1 is 3 and x2 is 5 and x1 is 2. So what is our slope now? It is 2.67. So it is also indicates the positive and negative factor. Here the slope indicates the positive line rises steeply, increasing approximately up to 2.67 units respectively. Now we are going to calculate the equation from slope and y-intercept. So we know that what is our slope and what is our, now we are going to calculate our intercept. So intercept, after calculating the intercept, our equation is y is equal to 4x minus 1. So we already know that our regression equation is y is equal to mx plus b. Now y is equal to 4x minus 1, which gives you for every unit of increase in x, the value of y increases by 4 units. So this is what as we mentioned in the previous slide, that is the first slide about the predictor variables. So that's all for today's this first session, and we will continue the next session in the next video. Thank you for listening the video.